Okay, welcome back to Number Sense Academy, and today we're going to take another deep dive into linear equations, and but we're going to look at how do we graph these linear equations. So we're going to look at the properties of these equations that make them easy to graph, or that facilitates graphing. And one of the things that we emphasize is, or I'm emphasizing, is that you should be able to look at the equation and picture in your mind exactly what's happening with the line before you even graph it. Now, once you graph it and you put it on um, in a visual, then you'd be able to make other observations that you might not have made in your mind when you look at the equation. And that's why we build visual. So we get to look at things differently, you get different perspectives, but the equation is the model and it lays the foundation for what your graph will look like. But then you actually graph it and you say, okay, now I see certain other things and see how things are interacting. So before we get into going from an equation to a graph, let's make sure that we're comfortable with certain things that are very, very essential to being able to graph. So, let me, so we are graphing linear equations. By now, you should be used to my poor penmanship, but it's neither here nor there. So, one of the things I want to talk about first is the idea of what we call the Cartesian plane. Cartesian plane. Now, if you're a mathematical historian, then you would know that this was invented by a gentleman named Rene Descartes, and his work was important for, I believe, trigonometry, and you can imagine perhaps navigation, stuff like that. I haven't looked into it, but if you have time, you can look into it. So, the Cartesian plane, it is found by the intersection of two axes. All right. Not only do they intersect, but they intersect at a 90-degree angle. All right. So if one side is 90 degrees, then the rest is obviously 90 degrees. So there's when these two intersect at a 90-degree angle, all the angles are also 90 degrees. So the axis that's running vertically, so this is called, or it's labeled as the y-axis. And the axis that runs left to right, this is the x-axis. And where they intersect, right in here, this is called the origin. Right, and that's a key piece because as you can see, these lines or these axes, they have these tails that have arrows. So they have the arrowheads. That means that they go on. That means these arrows go to infinity. So both positive infinity and negative infinity. And before they get there, they start somewhere. And the origin is right here in the middle. And the location of that origin, it takes on a value or a coordinate value, which would be 0, 0. And why is that important? Well, in the Cartesian plane, all over this plane, you have these points that are located all over this plane. And to get to these points, every single one of them starts out in the origin. Every single one. To map them, we're going to start in the origin, and we're going to do some counting in the direction of x and y to get to these values. Every single point. It has some relation to the origin. And we could do this forever. There's essentially infinite number of points inside of this. And each coordinate has some distance from the origin. And the value of the coordinate tells you the distance, not the calculated distance, but how far it is from the origin with respect to its direction in x and its direction in y. All right? So let me just expand that. I'll tell you what I mean by that. So in order to get to a point, you have to go either in the direction of x and then in the direction of y. Okay, so this would be your x value. And once you've completed going in the direction of y, you have now amassed two values, which is the x and y value. Now what we see, so say if this is the origin, what we end up seeing is just this distance, right? But what's happening underneath is what we actually do here to get to this point. Now this is for another time. You know that to get to between 2 points that intersect, you take the diagonal. So if they say this is a mountain, you're not going to walk into the mountain and then up in the mountain. That's like if there's an elevator, sure. Like you walk through a tunnel and then you get to the middle of the mountain and then you take the elevator up to the top. But no, we're going to be on the outside, which would be this diagonal. But even though we walk this diagonal, we could determine that we go in the direction forward and the direction upward. So a diagonal means that we go in a direction forward and then a direction upward. Okay, so recall that these 2 points, or these points, we call this a coordinate, right? So this is a coordinate. Let me write that down. It is a coordinate. And a coordinate has two values. It has an x value and a y value. So the direction of x and then direction of y. Okay, now do you have to go in the direction of x and the direction of y? If you're graphing, you're free to go in the direction of y and then the direction of x. It's the same thing. But when we talk about the technicalities and what's happening underneath, we try to say we deal with the run and then the rise. And even when we talked about the slope is rise over run, the ratio of rise over run. But as far as what's happening, we say how far are we going horizontally and then how high are we going vertically. So whenever I locate a point, so I'm going to just make up a point here and put it on this graph. So say I have this point. I'll just hijack this point. How did I get to this point? Well, I went down a certain amount of values, and then I went across a certain amount of values in the direction of x. So this point has a value x and y. Every single point in the plane has those properties. Okay, and another thing is, before we go on, is that a Cartesian plane is also known as a coordinate system. Coordinate system. So it's just a collection of coordinates. That's what the Cartesian plane is. Essentially, they're saying It's a collection of coordinates. All right? Okay. Moving on. In this plane, okay, as you can see, it's divided into 4 parts or 4 areas, and these areas we call quadrants. And not only that, we call them quadrants, but we also label them. So here we have Q1, here we have Q2, here we have Q3, and here we have Q4. Now there's something happening in each of these quadrants as far as the type or the value of the coordinates. All right. So what's happening? When I start at the origin and I move to the right in the direction of x, these are all positive values. Okay? In the same area, but if not even in the same area, but if I move to the left of the origin in the direction of x, these are all negative values. Likewise, or not likewise, but similarly, same thing. If I move in the direction of y vertically away from the origin, and I move upwards above the origin, these are also positive values. And if I move below the origin in the direction of y, these are negative values. So if I combine these together in the first quadrant, all my x and y coordinates are positive values. In quadrant 2, my x and y coordinates, the x values are positive, but the y values are negative. In quadrant 3, the x values are negative, and the y values are also negative. And then in quadrant 4, the x values are negative, and the y values are positive. Right? So if you're given a coordinate, before you even attempt or draw out the graph and determine where you're going to label it, you should already picture in your mind where this lies. So, for example, if I say here's a coordinate A and it has values -3, -2, you should be able to tell me that this is in Q3. Give you another coordinate 2 and 4. Both values are positive. This is in Q1. If I give you a coordinate C and I give you a negative value of x and a positive value of y, then you know that this is in Q4. And if I give you a positive value of x and a negative value of y, then we know that this is in Q2. Okay, so that's some important background on the quadrants. Okay. What else do we have? So let's jump back into our plane. So some important things about the x and y axis, or the values on the x and y axis. So we already know what happens to the values or the coordinates of the values that are outside of or these are kind of sitting in the general area of the plane. But now I want to pay attention to some of the values that are sitting on these axes. And they have some properties that you probably already make sense, or you already know. But let's just go over these anyways. So we know that there's infinitely many points along each of these lines. I'm talking infinite. Okay, they could be whole numbers, they could be rational numbers, they could be irrational numbers, they could be just not imaginary numbers. So essentially, all the points or the values within this coordinate system are real numbers. So maybe this point is -1. All right, so because it's not scaled properly, I could kind of give arbitrary values to these. Maybe this point is -1.999783. Okay, not quite 2. Maybe this point is -3.00048786. Maybe this point is bang on, -4. Or this is -5.12. Who knows? These are all real numbers, and this happens to anywhere in this plane where I could have these coordinates. Now, typically we work in whole numbers, but in reality, we could have any value. Now, these are the points on the line. So when we graph the line, we normally label them. I probably should have mentioned that before. So we have the origin, and then we'll come up with a scale, right? And we'll create some sort of these points, and we try to make them as properly distanced as possible. So this will be 1, 2, 3, 4, 5, and then I would do the same thing or a similar thing on the other side, and I'd have -1, -2, -3, -4, and then maybe I'd do the same thing here. Use a different color, right? And I could have 1, 2, 3, and then this would be 4, and so forth. I already did some examples down here. I'm using negative values, but some real values, right? So the points on these lines, though, however, their property is simple. Remember, as you go along, if I go along the x-axis, say if I want to go in the negative direction, so I start going this way. I'm going to start at the origin. I'm going to march my way in the negative direction, however far I might go. Or as I leave the origin, I go this way, however far I might go. Now, if I leave the origin and I get to a certain value, whatever that value is, and then I return to the origin, and I'm right here in the middle. The origin in the x direction is the y-axis. The origin in the x direction is the y-axis. All right? So this means that all the values on the y-axis, all the values on the y-axis have a coordinate with, well, not with, but they have a coordinate that looks like xy. Remember, there's an xy value, but all the x values is going to be 0 and some value of y. I'm going to put y star to mean that it could be any value of y. Okay, but the x value is always going to be 0 if it's sitting on the y-axis. Now let's do the same thing. If I think about if I'm traveling along the y-axis, I'm going to start at the origin. I'm going to travel down below, or I'm going to start at the origin and travel up to somewhere, to some point. When I hit the x-axis, remember that's the origin. So that tells me a similar thing. that all maybe I shouldn't say values. I'm going to say points or coordinates. All the points on, not in, the x-axis, all the points on the x-axis have a coordinate where we get a value of x, call it x star, and y is always 0. Y is always 0. So here, if it's sitting on the y-axis, x is 0. If it's sitting on the x-axis, then y is 0. All right, let's take this one step further before we actually get into some examples. So pertaining to the values on these axes, so these also have some important properties. So these could be just points in a line that cross the y-axis or the x-axis. But this could be a line that looks like this. So it has some direction, there's slope, or there's steepness. These 2 points, or this point and this point, the first one is called the y-intercept. And this y-intercept, it's just the point where the equation crosses the y-axis. So this is the point where not the equation, but the line crosses the y-axis. And the line comes from the equation, obviously. And then we have here the x-intercept. And it's the point where the line crosses the x-axis. And remember what we just did. At this point, so the point where the line crosses the y-axis, we know that x, as in the coordinate value of x, is 0. And the point where the line crosses the x-axis, the coordinate value of y is 0. And these are 2 important things that we're going to need when we get into graphing. And one more thing about the x-intercept. The x-intercept, this is also called the 0 of the equation. So this is something that's going to show back up when you get into graphing, or when you get into quadratic equations or cubic equations. We're interested in the zeros. For lines, there's only one 0 value because it's only going to cross the x-axis once. Once you get into quadratic equations and other functions, then you'll see that the curve could cross the x-axis many times, and then those would be the zeros. Typically, we reserve the term zeros for the x-axis, and y we just call them the y-intercept. Okay, so what about when it comes to graphing? When it comes to graphing, there's usually 3 techniques or methods used for graphing linear equation. 3 techniques that are used. Okay, we're going to go through all three of them, and I'm going to do an example for each to illustrate the point. And they'll be good examples so that you can transfer these to other questions that you might have from class or to prepare for your test. So the first option one, so there's three of these. I'm going to call it option one because they are options. You can pick whatever you want. Option one is what we call a table of values. Okay, so the thing with tables of values is that they can be easy to work with. I would say they're easy to work with depending on the function that you get, or depending on the equation that you get. Depending on the equation. Like equations with decimals and fractions, not so, doesn't work well with those. Not good for equations with fractions and decimals. You're going to find yourself doing a lot of work, a lot of calculations, and you can easily make a mistake. And for that same reason, they can be time consuming. All right, so unless if you're comfortable working with a table of values, that's great. But there could be some drawbacks where you spend a lot of time doing a lot of work that you don't need to. All right, so the way that they work is a table of values is you first choose values for x, solve the equation for y using each value of x, and the corresponding value of y for x, those two become a coordinate. The value for y obtained from solving for x so the values for y obtained from solving for x become a coordinate pair. I feel like that sentence is written terribly. The values, so whenever you solve the equation, so you have an x value, then you're going to solve the equation, you get a y value. Those two together become a pair. And then you use the pairs. I'm going to squeeze this in here. Use the pairs. You know what? This is not well said. And then we're going to graph the pairs. All right, I'm going to put here, you really only need two. All you need is two pairs. But there's a reason why you would try to get more than two pairs, and I'll talk about that in a second. So let's do an example. So we have this example, y is equal to 2x minus 1. All right, so the first thing we're going to do, we're going to set up our table of values. So remember, we're going to choose values of x, or for x. We're going to solve this equation here. We're going to solve this equation for y. And that's how we're going to populate the right-hand side of this table. All right? So I like to pick around 5 values, 2 below 0, 2 above, but I also like to include the y-intercept. And if the y-intercept in this case is -1. And I know at the y-intercept, the x value is 0. So that's kind of a given. So I'm going to put that in there because it's kind of a gimme. It's a giveaway. Right? So it's going to be 0, -1. And then I'm going to pick 2 values below and 2 values above. That's just how I like to do. So remember, all you need is 2 points to be able to graph. Once you have 2 points, it's great. The only thing is that I would say is if the 2 points are really close, it might make, and your graph is not really scaled. Now, if you're using a computer, it's going to be scaled. But if you're doing it yourself freehand, it might not be scaled. You might want to do 3 points just to kind of make sure you get a full. Gives you a better chance of getting a better line. But all you always ever need is 2 points. Okay, so now we're gonna all these remaining values, we're gonna plug them into the equation and get their corresponding y values. So the first one, I have y is equal to 2 times -2 minus 1. So this is -4 minus 1, which is equal to -5. So I get a -5 right here. And for the next -1, I'm going to get y is equal to 2 times -1 minus 1, which is -2 minus 1, which is -3. So I went from -5 to -3 to -1. You should probably see a pattern there. If you don't, I'll show you. So to get from -5 to -3, I just add 2. So the difference here is 2. To get from -3 to -1, I also add 2. -3 to -1 is 2. So what does that tell me? I just need to do this for the rest of these values. I'm just going to add 2. I don't need to use the equation anymore. I just need to add 2. So when I add 2 to -1, I end up with 1. And when I add 2 to this one here, when I add 2 to this one, or to the positive one, I end up with 3. And everything is 2 values apart. You should notice that these values of 2, this difference of 2, is related to this difference of 2. This 2, this first 2, is why this 2 is happening. All right? Why is that? Well, that's the slope. So m is equal to 2. 2 is the rise over run. And if you want to put this in fraction form, we know that this is 2 over 1. So this is telling me that a rise of 2 is a result of increasing x by 1. So when I increase x by 1, as in what I'm doing here, and I should also point this out, that the difference here, all these differences are 1s. Okay? And that also makes me recommend another point. For your x values, don't just pick like random values that are all over the place. You want to make sure that they're incrementing by 1 so that you have this property readily available. So we know what's happening. As we increase x by 1, we know the change in y. So we know the unit change in x is resulting in certain change in y. That's important. So the good thing is that now we have enough values that we can graph. So let's put this on a graph. So you always want to label your graph. And then the next thing you want to do, you want to come up with a numbering system that is properly scaled. So I have a -5 here, and I have a +3. I have a 2 here and a -2. So I want to make sure that my graph can take those values. So I'm going to, with -5, I'm going to go 1, 2, 3, 4, 5, and then 6. So I know this is -1, -2, -4, -5, -6. And then in the direction of positive direction of x. Actually, let's do this one. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. Then in x, 1, 2, 3, 4, 5. And you want to keep it nice and scaled properly, or else your graph's going to be terrible looking. And then -1, -2, -3, -4. Okay, so now we have a numbering system that we're comfortable with, and now we can start putting these points on the line and then completing the graphing. So my first point is going to be -2, -5. So I start at the origin and I go in the direction of x, so to -2, and then I go down to -5. So I'm going to count down all the way down. And that's my first point. So that's done. Go to my next point, -1, -3. So I'm going to locate -1, which is here, then I'm going to go down to -3. And it's right here. So that's, well, checked it before I even did it. And then my next point would be 0, 1, 0, -1, and that lies right on the y-axis. So that, this is my y-intercept. Just want to highlight it. This is my y-intercept. And then my next point would be 1 and 1. So 1 in the direction of y and up in the direction of x, and then 1 in the direction of y. And then 2 and 3, so 2 in the direction of x, and then up 3. And boom. And then now I'm going to connect these. Nice. And then the last thing I normally do is label my equation. So remember what I said. All you really need is 2 points. So if we had just the y-intercept and another point, then that would have been good enough. It would still pass through these points. Or I could get this point and then the y-intercept, then it would still work. Okay, so that's using a table of values. Option 2 is using the slope intercept. So when you have the slope intercept form, the two things that you need from the slope intercept form of the equation, the two things that you need are, one, the slope, right? Because that tells you the rise over the run. And then the second thing, you need the y-intercept. Because that gives you a coordinate that lies on the y-axis. Remember, that's going to be 0 and b. And this is your starting point. This is the first point on your line that you could readily identify. Okay, it's the first point on the line that you could readily identify. All right, so let's use an example. So if I have an example of -x plus 3y minus 6 is equal to 0, this is in general form. Okay, I'm going to convert it to slope-intercept form. So let's do that. So I need to get y by itself, so I have 3y. And I'm going to bring the x to where the 0 is. So that becomes positive x. And then the 6 also to the other side. That becomes positive x. But y is not alone. There's a 3 in front, so I have to divide everything by 3. And these cancel, of course, so I get y is equal to 1/3 x plus 2. So I write it as 1/3 x because I know that my slope is rise over 1, and I want it in that form, so 1/3. I want it in that form. And then the y-intercept, b, is 2, which gives me a coordinate of 0 and 2. So now I have the information that I need to graph. So this is y, this is x. All right, so I don't know how big these values can get, but I could sort of take a guess as to what's going to happen. So let's think about it. The first thing I have is this. This is my y-intercept. So I need to at least have a 0, a 2 on the y-axis. And then this tells me I'm going to rise 1. So I don't need a whole lot of y values. I'm going to go from 2 up 1. But then I'm going to run 3. So I'm going to go up 1, run 3, up 1, run 3. So that means I need more x values than I need y values. So I'm going to use that to dictate how I scale this graph. So I'm going to keep the values a little bit smaller. So we know we have the origin. 1, 2, 3, 4, 5, 6, 7, 8. Okay, because I'm starting at a positive value, like I'm not starting on the negative side. Like I'm not starting down here. So because I'm not starting down here, I'm not going to put a lot of emphasis on the negative value. So I'm going to put a couple. So -1, -2. And same thing with the negative side of x, because I'm going to go up and to the right. I'm going to up and to the right. Everything I'm going to go to the right. So I'm not going to put a lot of negative values here. I'm going to put about 3. And then for y, I'm also not rising a whole lot, but I need to have at least, say maybe 6. 1, 2, 3, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then the first thing I'm going to do, I'm going to locate my y-intercept, which we know is at 0, 2. So that is right there. All right. And now I'm going to follow the rise over run, which says you need to go up 1 and then across 3. So let's do that. So we're going to go up 1, so from 2 to 3, and then across 3. That's going to take me over to about here. And that's all I need to do my graphing. But just to show, I'm going to do another one. So I'm going to go up 1 to 4, then across to 6. And now I could connect the dots. Another thing I could do, because I'm still going up to the right, I could go down 1 and to the left 3. So just for fun, I'm going to do that. So I'm already here. I'm not going to go down 1. I'm just going to go to the left 3. Yeah, down 1 and to the left 3. And now I have another point here. Okay, and now I connect these points. Okay, and my equation is y is equal to 1/3 x plus 2. Or you could write it in general form if you want. So this same equation is minus x plus 3y minus 6 equals 0, if you want. Now, before we get to the next one, I want to point out an important thing. If you notice this line, it has a y-intercept, and it intersects the x value at a certain point. This will help us figure out our next option. So our final option is option 3, and this is to use x-intercept and the y-intercept to graph the line. Okay, so suppose we have an equation. Our equation is y is equal to, that's not our equation. Our equation is 2x plus y equals 4. So all we're going to do is find the x-intercept and the y-intercept. And that goes back to my point. All you need is 2 points to graph the equation of a line. So if we want to find, let's first find the x-intercept. And for that, we're going to let y equal 0. Why are we letting y equal 0? because we know when we're sitting on the x-axis, no matter where we are on the x-axis, y is equal to 0. So that's why we let y equal 0. So now I'm going to sub y equals 0 into the equation. I end up 2x plus 0 equals 4, which means that 2x is equal to 4, which means that we divide everything by 2, and x is equal to 2. So the coordinate for the x-intercept, as we expect, is 2, 0, because y is 0 and x is 2. So we just plug those there. Now let's do the y-intercept. So over here, we're going to let x equals 0. So I have 2 times 0 plus y equals 4. 2 times 0 is 0, so what I'm left with is y is equal to 4. So I have x equals 0 and y is equal to 4. So that coordinate becomes x is 0 and y is equal to 4. Now I could graph. So again, I'm going to use that information to build my graph. Okay, so let's look at what we have. We have a coordinate of 2 and 0. So I want to scale my graph, right? We have a coordinate of 2 and 0. And 0 and 4. So I'm just going to find those points. So x, 0 and 4, this is the y-intercept. So I need at least 4 values on the y-intercept. So 1, 2, 3, 4, 5. So I'm going to put 5. Where's 0 and 4? 0 and 4 is right here. All right. And then for the x-axis, I need 2 points at least. So let's go 1. We'll put those. And then that point is 2 and 0. So that's here. Okay. So remember, this is the y-intercept. And this is the x-intercept. And then I just connect the two. Okay, graph is not, or the line is not straight, but that's okay. And my writing is not good. That's also okay. So 2x plus y equals 4. So that's the equation. All right? And that's how you graph equations of lines. So the 3 options, you can use a table of values, or you can use the slope-intercept. So convert the equation, whatever form it is, make sure it's in slope-intercept form. And then you could use the x-intercept and y-intercept. That's it. Thank you.